Hey Math 85, this is Dr. McGathy, and we're starting section 8.2 on the multiplication and division properties of equality. So basically what we want to do is solve equations by multiplying or dividing both sides of our equation by the same amount. And the reason that works is because if you have numbers A and B and C, if you know that A equals B, then multiplying both sides of that equation by a number C makes another true statement. And dividing A divided by C, B divided by C, dividing both sides by C also makes a true statement. This is all, of course, as long as C is not zero. So basically what we're going to be doing in this section, solving equations by manipulating an equation by multiplying or dividing both sides by the same amount until we have the variable all by itself on the left-hand side or on one side, and the solution will then be on the other. So let's give this a try. Let's solve 4x equals negative 28. So again, what we always want to look for is like, what's the operation connecting the number to the variable? Whatever that operation is, do the inverse operation. So this is 4 times x. So to undo multiplying, we will perform division. So divide this side by 4, divide that side by 4. 4x divided by 4, we are just left with x equals a negative 28 divided by 4 is a negative 7. Then we can check our answer by plugging this number into the equation. 4 times x, which I'll write as negative 7, equals negative 28. Is that true? Yes, because 4 times negative 7 is negative 28. Okay. Let's do another one. A divided by negative 7 equals negative 42. So I want to manipulate this equation so that I have A by itself. So the operation here is division. So I'm going to perform the opposite of division, or the inverse of division, which is multiplication. So I'll multiply this side by times negative 7, and this side times negative 7. And again, we should recognize, like with fractions, this is like negative 7 over 1. The reason this leaves me with just A is because it's got a common factor of negative 7 in the numerator and denominator. So that leaves me with just A on the left, and negative 42 times negative 7. Well, I know it'll be positive, and let me go ahead and see what 42 times 7 is off to the side. 7 times 2 is 14, 7 times 4 is 28, plus 1 is 29. So A equals 294. And then you can always check by taking A divided by negative 7. So 294 divided by negative 7, you should get negative 42. All right, the next one is one that typically confuses us, but is really easy. Negative r equals 2. What does r equal then? So there's a couple ways to think about this, and I'll just go through them. One is to say that this is not just negative r, but negative 1 times r. So you can think about dividing both sides by negative 1. And you get r equals 2 divided by negative 1, which is a negative 2. Right? My favorite way to think about this problem, however, is to think of like another operation. I like to call it negation. So negative r equals 2, but I want this to be a positive r. So what I'll do is negate both sides of this equation. Just make them both negative. So double negative is a positive. So now I have r equals negative 2. Either way, you get the correct solution. All right, let's look at the next problem. 2/3 x equals 18. So I'm multiplying here 2/3 times x. So in order to get x by itself, I really should perform division. So I'll divide both sides by 2/3. But instead of doing that, let me actually write that off to the side here, because that's not what I want to write on my paper. It's not what I'm going to write every time. I have 2/3 x equals 18. And we divide both sides. So like divide by 2/3. Divide divide by 2/3. Dividing by 2/3 is the same as multiplying by the reciprocal of 2/3. So instead of writing this, actually, when I'm dealing with fractions, I'm just going to multiply by the reciprocal right away. That's how I will get rid of my fraction factors. So 3/2 times 2/3, notice that one nice thing that you'll know if you're doing it the right way is if the factor in the numerator cancels with your factor in the denominator here, and same thing with these cross terms. Everything kind of cancels and leaves you with just x. All right, and here, 18 times 3/2. Remember, when you're multiplying with fractions, you want to treat that whole number as a fraction with denominator 1. And then typically you look at the cross terms and see if they have any factors in common. 18 and 2, yes, 2 does divide into both of those numbers. 18 divided by 2 is 9. 2 divided by 2 is just 1. So 9 times 3 is 27. Over 1 times 1 is 1, and I will not write that because it's a 1 in the denominator. And because this one took us so long, let's go ahead and just check our answer here. The original equation was 2/3 times x, which is now 27. Let's see if that's equal to 18. Again, I'll perform fraction multiplication. Look at those cross terms, 2 and 1, that's already, is reduced as far as it can go. 3 and 27. Both have a common factor of 3. So 27 divided by 3 is 9. 3 divided by 3 is 1. 2 times 9 is 18 in the numerator. 1 times 1, 1 in the denominator. You got 18 equals 18, which is great.